1 2014 A is equal to P, Q, R, S. And B is equal to P square plus Q square, PR plus QS, PR plus QS, R square plus S square. Full stop. If rank A is N, then rank B is there. (2007). If X is a non-zero vector of dimension 3 cross 1, then the matrix A is equal to X into X transpose has rank is equal to dash. First solution. So, I can write B matrix as P square as P into P plus Q square Q into Q. And this P into R plus Q into S. And this is P into R plus Q into S. And R into R plus S into S. Okay. So, in this, I can write this is P, Q, R, S into P, R, Q, S. So, it is a product of two matrices. One is the transpose of other. Just check that. First row multiplied by first column, P square plus Q square. PR plus QS. RP plus SQ. RP is nothing but SQ. Okay. I can write like this also. To satisfy, to understand well, R into P plus S into Q. Next, second row into second column, R into R square plus S into S square. So, which is nothing but A into A transpose. Therefore, rank B, the quotient requires, is equal to rank of A into A transpose, which is nothing but rank A. Why? A into A transpose into A transpose A, all these four matrices having same ranks. Okay? Using property 3. Just refer property 3. So, rank A is already given N. So, rank B is also N. Okay? Next. Second solution. So, go to the question, non-zero vector. Vector means either row or column. But here I mentioned the order, 3 cross 1. 3 rows, 1 column. So, clearly, X is a column vector. Non-zero means at least one element is not equal to 0. So, sorry, clearly, X is column vector. Non-zero mentioned already. So, what is the rank of a column matrix? Is 1. That is property 2. Therefore, rank of X is equal to 1 since property 2. Next. Therefore, they are asking the question rank A. What is matrix A given X into X transpose? So X into X transpose looks like property 3 A into A transpose, whose rank is same as matrix A rank. That means X into X transpose having rank same as rank of a matrix X since property 3. Rank of X already we got 1. So hence rank of the given matrix A is also 1. Definition. A system of simultaneous linear equations is said to be consistent if it has a solution. Otherwise, given equations are called inconsistent. That is, solution does not exist. It is of two types. Number 1, Ax is equal to B in bracket called non-homogeneous equations. EQS stands for equations. 2, Ax equal to O in bracket these equations called homogeneous equations. This B not equal to null matrix. So, equations you know. Left hand side containing variables, right hand side some numbers, zero numbers or non-zero numbers. Linear equation means each term having power 1. That means each variable is also called unknown. For example, x plus y is equal to 6. X power 1, y power 1. So, no product term. Such equations are called linear equations. So, given equations, that means either one equation or two equations or three equations, given equations or four equations, all are called linear equations only. System of linear equations. It is said to be consistent. Consistent means that equations having a solution. Having a solution means while solving you have to get x value, y value, z value, some answers. Okay. Otherwise, the given equations are called inconsistent. What is inconsistent means? No solution. That means x value, y value, z value does not exist. No answers. Okay. So, for example, see, x minus y is equal to 1. X minus y is equal to 0. How to solve these two equations? In our childhood class, 7th, 8th, 9th, just by eliminating or adding, subtracting or substitution method. So many methods we have learnt. For example, if I subtract, both x, y is gone. You won't get x value, either y value. Moreover, x and y are some numbers. Okay, let us say some numbers. If you find the difference, everyone should get answer, one answer only. When x and y are some numbers, we don't know, find the difference. Minus means difference. So, when you take the difference, everyone should get one answer or not. But here on the right side, 1 and 0. Left side, same. So, this is an example of inconsistent equations. Okay, x plus y is equal to 1. X minus y is equal to 1. How do you solve in our childhood class? Just by adding, we'll give x value 1 and y value 0. Okay, so this gives one solution only, unique solution. Okay, similarly, while solving some equations, infinitely many answers. So, what is solution here? SOL stands for solution. X equal to 1, y is equal to 0. And all last values x, y, z, whatever it may be, they have to satisfy at a time all the equations. That is called simultaneous equations. So, whatever you are getting the answers x, y values, they have to satisfy first equation, second equation, etc. every equation in the given problem. Then only that is called solution. Okay, if first equation satisfied, don't say immediately that is solution. It has to satisfy second equation also. For example, x minus y is equal to 1. So, has x equal to 1, y equal to 0. X equal to 0, y equal to minus 1. X equal to 2, y is equal to 1. X is equal to minus 1, y is equal to minus 2. So, like that, see, unlimited solutions, uncountable solutions, so many solutions, infinitely many solutions. So, solution means either unique solution or infinitely many solutions. These are called consistent equations. No solution means that equations are called inconsistent. Okay. So, whenever all the right hand side equal to 0, variables belongs to left side, right hand side some constants. If all constants are 0, such equations are called homogeneous equations, which is matrix form can be written as Ax equal to 0. Whenever at least one of the right hand side of the equation is not equal to 0, such equations are called non-homogeneous equations, which can be put in the matrix form as Ax equal to b. So, how do you write this Ax, b? I will show you. A is called coefficient matrix. X is called column matrix, which contain variables or unknowns of the given equations. B is also a column matrix, which contain elements on the right hand side of the given equation. And O is a null matrix, which is exclusively column matrix. Okay. A is called coefficient matrix. That means all the coefficients of x, y, z in the given equations, put in a matrix. That matrix is called coefficient matrix denoted by A. X is a column matrix whose elements are called unknowns or variables. B is a non-zero column matrix. O is also a column matrix. Okay. And finally, a new matrix that is denoted by C, which is obtained by combined matrices of A and B. That is side by side matrix. Don't say A divided B. So this is just an indication. A elements, that means A matrix followed by B matrix, which can be put together in a matrix which is denoted by C. Such a matrix is called augmented matrix. Is called this is useful for solving in 12th class Gauss-Jordan method for solving some equations. We have learned solving these equations in 12th, 11th class. Matrices chapter, Cramer's rule, matrix inversion method, that is Gauss-Jordan method, that is over. But this is, we are going to solve by reducing the matrix into row echelon form by using rank method definitions only. We are finding solutions, which is the easiest way. It's a rare case, some problems by determinant method also we can decide the solution. Okay. See, example, x plus y minus z is equal to 1. X minus 2z is equal to minus 1. X minus y plus 3z or 2x is equal to 0. How many equations? I consider 3 equations. How many variables? 3 variables, which are also called unknowns, x, y, z. Okay. So these are, one of the right hand side is not equal to 0. So these are 3 non-homogeneous equations in 3 unknowns, x, y, z. Am I correct or not? So how to write from this? A matrix, coefficient, that is x, y, z coefficients in the left hand side of the equation. 1, 1, minus 1. Here x coefficient 1, y coefficient 1, z coefficient minus 1. That is first row, first equation. Second equation corresponds to second row. X coefficient 1, y is absent. When a variable is absent, its coefficient is 0. So 1, 0, z coefficient is minus 2. Third row equation, all variables present. 2, minus 1, 3. X is a column matrix containing variables, x, y, z. B is a column matrix containing the elements which are belonging to right side of the given equations, 1, minus 1, 0. These are the numbers on the right hand side of the given equations. Okay. So finally, C matrix, that is combined matrices A and B together put in a matrix denoted by C, which is called augment matrix. So 1, 1, minus 1, 1, 0, minus 2, 2, minus 1, 3, up to this A matrix. This is an indication, that line. Now B matrix put here, 1, minus 1, 0. So this is called combined matrices of A and B, which is A by B, that is separately denoted by C matrix, which is known as augmented matrix, which is helpful for solving Ax equal to B equations. Okay. So x plus y, 0. X minus y, 0. How many equations? 2 equations in 2 variables are 2 homogeneous equations in 2 unknowns, x comma y. So unknowns can be denoted by x, y, z variables or x1, x2, x3, y1, y2, y3, alpha, beta, gamma. They can represent, they can denote any notation. Okay. So because all the equations right hand side 0, such equations, such a system is called homogeneous system. Otherwise it is called non-homogeneous system. Okay. Now how do you solve each type of equation? I am giving the short method procedure. Okay. procedure for solving homogeneous equations Ax is equal to B. Step 1. Reduce matrix C, that is A by B, into row echelon form. Which we have learned by 3 examples of previous definition. Step 2. 3 cases. Number 1, if rank A is equal to rank C, then Ax is equal to B is consistent. In this, if rank A is equal to rank C is equal to n, n means number of unknowns, or using 11th class method, determinant A not equal to 0, which is easy in some problems, not easy in some other problems, then Ax is equal to B has unique solution. If rank A is equal to rank C less than n, n means number of variables, or det A equal to 0, comma, adjoint of matrix A into B is also 0, then Ax is equal to B has infinitely many solutions. Number 2, in condition 1, 3 points. If rank A not equal to rank C, or det A is equal to 0, comma, adjoint A into B not equal to 0, then Ax is equal to B has no solution. That is inconsistent. So please write, I will explain. N is number of unknowns. So everyone remember the procedure for rank? So you have additional matrix, that is A by B, C matrix only, take care. Step 1 is reduce this new matrix C, which is the combined matrices of left side numbers, right side numbers of the given equation, that is A by B, into row echelon form. What is the purpose of row echelon form? Which gives rank of that matrix. When a matrix C is row echelon form, automatically the matrix A is also row echelon form. So when you are finding rank C, in that step, it will give rank A matrix also by closing the last column. What is the difference between A and C? A followed by, that means after A matrix, we are writing B matrix. So that C matrix has one more column extra compared to number of columns in matrix A. So when you close the last column in the matrix C, the remaining columns are nothing but matrix A. So when you have rank of a matrix C, there you will get automatically rank of matrix A. Don't find separately matrix A rank. Now, when A and C have both ranks, then the equations are consistent. What is the meaning of consistent? The equations having a solution. When both, in this part 1, step 2, first point, both ranks equal to number of variables. Or this is 11th class, 12th class method, that A not equal 0. Then the Ax equal to B. What is Ax equal to B? Given equations written in matrix form. That means given equations have unique solution. Unique solution means only one answer for x, y, z values. When both ranks equal but less than number of variables, n stands for number of variables or unknowns, or this condition, then the given equations have infinitely many solutions. Given equations means Ax equal to B. When both ranks unequal, then the given equations have no solution. No solution is the meaning of inconsistent. I told you already. N is the number of unknowns. Please at a glance keep these points in mind. We'll start with one example first. Number 1, this question asked in 2014, 2 marks. The equations, so I am writing EQS. EQS stands for equations, short form. Three x plus 2y is equal to 1, comma 4x plus 7z is equal to 1, comma x plus y plus z is equal to 3, comma x minus 2y plus 7z is equal to 0. Have option a unique solution. Option B, 2 solutions only. SOL stands for solution. SOLS stands for solutions. C, infinite number of solutions. D, no solution. 4 options provided. Solution. So, how many equations? It doesn't matter of number of equations because we have to approach by this procedure. But anyhow, I will discuss each problem. 4 equations. We have never seen in our childhood class 9th, 10th or 11th also 4 equations. Maximum 3 equations, 3 variables like that. Here 4 equations, 3 variables, x, y, z. More equations, less number of variables. This is one type of equations. Okay. So, n is equal to 3. That is x, y, z. And 4 equations. Understood or not? Now, the first step is writing the augmented matrix A by B, combined matrices of A and B, which is nothing but 3, 2. First equation Z is option 0. The last right hand side element is 1. Next, second equation 4. Y is option 0, 7, 1. Third equation, all are present. 1, 1, 1, 3. Fourth equation, 1 minus 2, 7, 0. This is the beginning of step 1. We have to reduce this matrix into row echelon form. So I hope that everyone well remembered and following each and every step. So the first non-zero element is 3. We should make its down elements 3. There are 3 down elements. R2 element, R3 element, R4 element. With the help of R1, we have to apply some row operations and we'll make zeros. So what are that? Here I am writing. How do you make 4 0? Here with the help of 3. Here I have to multiply by 3 and here I have to multiply 4. So you will be getting 12, 12. 12 minus 12, 0. So applying 3 R3, 3 R2 minus 4 R1. Next, how do you make this one element 0? With the help of this 3, we have to get here 3. That means multiply R3 with 3. 3 R3 minus R1. Again, how do you make this 1 fourth row element 1 0? By multiplying with 3, we will be getting 3. 3 minus 3, 0. So again, applying 3 R4 minus R1. So be ensured that the second position should be same. That means you are doing in a correct way. It means that doesn't mean that correct way. You never get silly mistakes if you do like me that operations. R2 changes, R3 changes, R4 changes. Okay. So you will be getting a new matrix where R1 is no change. Same elements 3, 2, 0, 1. Next, hold like this. 3 R2, 3 into 4 minus 4 into 3. 12 minus 12, 0. 3 into 0 minus 4 into 2, minus 8. 3 into 7 minus 4 into 0, that is 21. 3 into 1 minus 4 into 1, that means minus 1. Next, hold like this. R3 with R1. 3 R3 minus R1. So 3 into 1 minus 3 becomes 0. 3 into 1 minus 2, 1. 3 into 1 minus 0 simplifies to 3. 3 into 3 minus 1, that is 8. Next, R4 with R1. 3 R4 minus R1. So 3 into 1 minus 3, that is 0. 3 into minus 2, minus 2. Minus 6 minus 2, minus 8. 3 into 7 minus 0, that is simplifies to 21. 3 into 0 minus 1 simplifies to minus 1. This is the next step. Okay? So the first non-zero element in the second row is minus 8. We should make down element 0. That means this 1 and minus 8 we have to make 0 with the help of this minus 8. So make R3 element, R4 element with the help of R2. By applying row operations, make them to be 0. That means how much number I have to get here? Because here minus 8, you should get plus 8 or minus 8. So just multiplying R3 with 8 and adding with R2 element. So that means 8 R3 plus R2. So R3 changes. Next, how do you make this minus 8 0? Already this is minus 8 just by subtracting. Same numbers if there, that is either adding or subtracting. So R4 minus R2. So R4 changes. So equivalent to here R3, R4 in the next step changes. R1, R2 remains same. 3, 2, 0, 1. 0 minus 8, 21 minus 1. 0, that is 8 into 0 minus 0. 8 into 0, 8 R3 plus R2. 8 into 0 plus 0, 0. 8 into 1 minus 8, that is 0. 8 into 3, 24 minus 21, 3. Okay. 8 into 8, 64 plus minus 1. So 63. Next, R4 minus R2, 0 minus 0, 0. Minus 8 minus half minus 8, that is plus 8, minus 8 plus 8, 0. 21 minus 21, 0. Minus 1 minus half minus 1 becomes 0. So let me check here. I have done a silly mistake. 8 R3, 8 into 3, 24 plus R2, that is 21. 24 plus 21, 45, not 3. 45. So here, first non-zero element in the first row, first non-zero element in the second row, first non-zero element in the third row. Just observe my circles. When each circle compared to preceding circles, it should lie on the right hand side. That means elements below the circles are 0. That means elements below the diagonal also 0. So this is. Understood or not? So the last row here happens 0 row also. Is row echelon form. Okay. Therefore, now take care in this. We are finding not only rank of the matrix C, but also A. That means elements below the diagonal, 0. So if I close last column, the first 3 columns is matrix A. Still matrix A is also row echelon form. What is the rank of this matrix? 3 non-zero rows. So rank A is equal to 3. If I open, this is the 16 elements which is C matrix. Still it is row echelon form. So how many non-zero rows? 3 non-zero. So both A and C have same rank which is equal to 3. Rank A is equal to, rank C is equal to 3. This 3 is equal to n value 3. So both ranks equal to n. This is step 1. Step 2, first point C, rank A is equal to rank C is equal to n. Then the equations are unique solution. Therefore, unique solution. So accordingly, answer is option A. Copy it. Second example, asked in 2015 GATE, 2 marks. Sorry. The value of K for which the system x minus 2y plus 3z is equal to minus 1 comma x minus 3y plus 4z is equal to 1 comma minus 2x plus 4y minus 6z is equal to k has infinitely many solutions, comma is dash. Solution. So already some hint is provided. These equations have infinity solution. They are not asking which type of solution. They are asking some k value, which is either right side or left side. You observe. In the third equation, that k is presented in the right hand side of the equation. So n is equal to 3. 3 variables x, y, z. Okay. Comma. 3 equations. So here number of equations is same as number of variables. In the previous problem, more equations, less variables. Okay. Now, C matrix A by B is equal to 1 minus 2, 3 minus 1. 1 minus 3, 4, 1 minus 2, 4 minus 6, k. So, what is given information? Infinitely many solution. Either applying by rank and taking this condition, or use that a 0 also. Okay. For infinitely many solutions, we have rank A is equal to rank C less than n. This n, 3 stands for, so rank, what is the matrix A? This is 3 by 3, less than 3. So just to refer rank properties, okay, that is fourth property. Rank of A n cross n is equal to n. Such matrix is non-singular. Rank of A n cross n less than n. Such matrix is singular. So implies determinant A is equal to 0. Or you can take directly, I provided here that A 0 also, using rank method, or that A equal to 0. So generally when they give or when they are providing infinitely many solutions, immediately you take the condition that A 0, that A is equal to 0 is obtained by the properties, fourth properties of rank definition. Understood or not? Okay. Now, so what is that? That means 1. Wait, kindly excuse me. So in this case, I cannot get k because this k is belong to B matrix. So if this k belongs to in any one of the row or column in the A matrix, then this condition is useful. So better apply row operations only. Kindly excuse me. Don't take immediately infinite many solutions. This k belongs to the last column, which is not A matrix. So as usual, reduce this matrix into row echelon form. Okay. So this is the first non-zero element in the first row. Make its down elements. That is R2 element number 1, R3 element minus 2. We have to make 0 with the help of R1 number 1 element. So applying R2 minus R1, R3 plus 2R1 equivalent to, so R2 changes, R3 changes. You will be getting a new matrix where R1 remains same, 1 minus 2, 3 minus 1. Next, R2 minus R1 means 1 minus 1, 0. Minus 3 minus of minus 2 simplifies to minus 1. 4 minus 3, 1. 1 minus of minus 1 simplifies to 2. Next, minus 2 plus 2 into 1, 0. This is 4. 4 plus 2 into minus 2, 4 minus 4, 0. Minus 6 plus 2 into 3, minus 6 plus 6, 0. K plus 2 into minus 1, this is k minus 2. Okay. Now, this is the next non-zero element in the second row. This is the first non-zero element in the first row. So, and we don't know k value. I cannot say this k minus 2 is 0 or non-zero. So anyhow, in the closing the last column, which is nothing but remaining 3 columns A matrix. So it is already row echelon form. Are you following or not? Below the diagonal, 0. So this is row echelon form. Now rank A is equal to 2. Okay. For infinitely many solutions, this is already provided information. We have, what is the formula provided? Rank A is equal to rank C less than 2. Rank A is equal to rank C less than 3. What is this 3 stands for? Number of variables. So, since rank A is equal to 2, because 2 non-zero rows, therefore rank C is also 2. What is the rank of a matrix definition? A matrix having the number of non-zero rows is called rank of that matrix, provided that matrix is row echelon form. Okay. So here I am doing rank C is also 2. When rank of this matrix 2 means that matrix has 2 non-zero rows only, that means k minus 2 is 0. Therefore matrix C must has 2 non-zero rows only. Implies last row is 0. Therefore, last row 0 means already 3 elements 0. K minus 2 is equal to 0. Implies K is equal to 2. This is the answer. Both ranks equal less than 3. So, rank A 2. 2 is always less than 3. Because of this condition, rank C is also 2. What is the rank of a matrix definition? Number of non-zero rows. So, because rank of this C matrix is 2, so the matrix C only having 2 non-zero rows, must has 2 non-zero rows only. That means already C matrix having 3 rows, the first 2 rows having 2 circles, the first 2 rows are non-zero rows, the third row must be 0 row. That means last row is 0. K minus 2 is equal to 0. Have a break.